Hello friends, welcome back to my YouTube channel. In this video, we are going to discuss a very important design pattern in intelligent systems, the goal setting and monitoring design patterns. So this pattern is the backbone of autonomous agentic AI systems and decision making workflow. So it is helping a system to define a clear goal, track a progress, detect failures and take corrective action automatically. So I will explain everything in a simple practical way with real time examples you can apply directly. So without wasting any time, let's get started. So goals and monitoring design patterns. So the goal setting and monitoring agentic patterns is way to design a system, AI system, so that it behaves like a manager, not a just like a worker. Instead of blindly executing any instructions, the AI knows what it's trying to achieve, continuously check how well it's doing, noticed it notice when things start going wrong, and it will fix automatically itself without waiting for the humans, right? So the core idea is a like it's think a human manager. It set a goal, it track the KPI, and it notice the performance drops, and it take the corrective actions. So this pattern gives AI agents the same capabilities. So this pattern enables an AI agent to understand explicit goals. So the agent must clearly understand what success means. For example, they keep system latency under 50 milliseconds, increase recommendation CTR, click through rate by 5%, and maximize trading profits with low risk. So the key idea for this understand the explicit goal is to it must be measurable, not the wage. It reduce rate error below 1%. KPIs. So once the goal is defined, the agent track KPI, key performance indicator, in real time. So example of KPI is accuracy, precision recall, and revenue conversion rate, low latency, error rate, CPR, cost per request. Next is detect drift and delegations. So over time, condition change and user behavior changes. Data drifting shift is happening, and market become so volatile, and this is called the drift. So what type of problem detected here? So KPI is slowly declining, and it becomes sudden downgrade of performance drop. Input data not longer looks familiar, and prediction becoming unstable. So and course correct. So when the agents detect a problem, it does not panic or stop, it adapts it. The possible correction may be it retrains or switch models, it adjusts the threshold, ignore bad data, and it scale it. So this happens automatically based on the predefined rules or learned policies. Next is the core components. So first is the goal definition agents. So it translates the business intent to the machine understandable objectives. So its example is it reduced the prediction latency less than 50 milliseconds, and cost per request is less than equal to 1%. Next is KPI monitoring. So it continuously measures system health and goal progress. There are multiple KPI types. Like first is business. So it's talk about the CTR, revenue churns, and the model is talk about the accuracy, F1 latency, data missing percentage, schema violations, and system, that is the throughput error rate. And a streaming matrix often comes from a Kafka, Spring, Spark feature store. Drift detection agents. So detect when reality diverged from assumptions. So there are multiple drift also. Type of drift is here. So this is the data drift. This is the concept drift. This is the prediction drift. This is the performance drift. And it's having the common techniques to get it. We use the KS test, PSI population stability index, and rolling window baselines. Next is evaluation and decision agents. It decides whether intervention is needed. If the KPI drops is greater than threshold or drift score and is greater than limits, so it trigger the course corrections. The decision policy can be rule based, LLM, region, and reinforcement learning. Course correct agents is take the corrective action automatically. And the possible actions is data, just we reweight the sample, filter noise, model, retrain, fallback, and switch models, and systems that scale infra and reduce features, strategy, change decision thresholds. So the agentic control loop, it's look like first is goal setting, then KPI observed, then is any drift detected, then decide and region and decide, then take the corrective actions, then re-evaluate. So this loop run continuously, enabling the AI system to self-monitors, self-diagnose, and self-correct. So if we talk about the goal set, so this is where the agent is given clear and measurable objectives. Second one is the KPI. So KPI is talk about the agent continuously measure KPIs. This is the KPI. So what is the object? The business matrices like revenue and CTRs, and drift detected where it's talk about the agent compare a company KPIs and data against. Then region and decide. Once a problem is detected, the agent reason about the uh, cause and decide whether the action is needed, and the correct action is fix the course. The agent takes targeted correlate active actions, and then re-evaluate. After action is taken, the agent measures KPI again, verify the improvements, ensure no side effects. So why this loop, this in-to-in loop is so powerful? So traditional systems is static monitoring, and we have to do the manual fixes, and reactive, right? And agentic loop means this loop is a continuous intelligence, autonomous corrections, early detection, and proactive. So this loop turns an AI systems into a self-awareness of self-correcting entity that continuously steers itself towards its goal. So few of them are design best practices, that is separation of concerns. So planning agent is not the monitoring agent, and monitoring while doing the monitoring, so you're not taking the decision making. So HITL, human in the loop, that is optional. It's high risk action required approval, low risk action auto executes. That is the observability, that everything decision locked, explainable reasoning why correction happens is talk about. Then when to use, when we have the real-time systems, then financial performance, recommendation engines, autonomous decision systems, and When we don't use this one, this goals and setting design pattern, when we have a simple batch pipeline. So this is the theory part of goals and setting and monitoring agentic design patterns. Next is next is next is I we can discuss about the architectural flow. So this is a clean end-to-end explanation of flow shown in agentic framework diagram, how a user request moves through a system and how intelligence, safety and learning are applied here. So high level idea. So this diagram represents a kind of production ready agentic AI systems where a LLM coordinate multiple agents. Its work can be sequentially and parallelly, and decision are planned, executed, validated, and corrected, and the system remembers, observes, and improves over times. So if we talk about the flow executions, so starting from the left, the user input enters, the user send a request, query task instruction, the system boundary is there, receive it and route in it to inward to the planning agent. The planning agent is the orchestrator. So planning is the brain that decide what need to be done, which actions are required. Should the task run sequentially or in parallelly? It converts a request into the execution plan for like agent 1, agent 2, agent 3. So agent 1 is for data analysis, for example. Second one is the trend detection. Third one is the recommendation generation. Third one is the third agentic framework LLM driven core. LLM driven, this one. So at the top of the this is at the top of LLM model, which provides reasoning, maintain task context, coordinate agents. So the LLM does not do everything itself, else it will degrade. Next one is the execution path. So execution path is the two modes. First is the sequential and next one is the parallel. This is sequential and parallel. So sequential workflow, agent 1, agent 2, agent 3, and when to use each step dependent on the previous one, and output must be defined as step by steps. Then I will go with the sequential workflow. Second one is parallel workflow. So the when we go, so tasks are independent and faster execution is needed. So one agent analyze sales, another agent analyze customer behavior, and third agent, the decision agents, merge their insights. Now to talk about the decision agents, this is for the judgments and synthesize. The decision agents collect the output from the multiple agents, and it resolve the conflicts and choose the best answer and goals. Next one is guardrails, that is for the safety and control layers. So before anything reaches to the user, the guardrail validate the policy validations, unsafe action, hallucination, and authorized data access. So only approved output are allowed to this gate. This is very critical for enterprise AI, regulated industries, and autonomous agents. And next is the systems. The systems here. This is the final output. So once the guardrails approve it, the response is returned to the users or action to be executed by the systems. And the below one is a memory layer, that is for long-term intelligence here. So the system stores and retrieves memory from chat history, user profile, and conversation states. So this allows personalizations, multi-turn reasoning, continuity across sessions. And next layer is observability and analytics. So eye of the systems. So this layer continuously track agent performance, latency, errors, and decisions quality, and also the drift or the failures. So this observability and analytics enables the debugging, auditing, and system health monitorings. And one more layer is the feedback loop, that is agent and learning here. In the dotted line, if you see agent adaptation and learning, that this is the feedback loop. This is a continuous improvement. So it's coming from system and going to the planning loop, this loop. So the past outcome influence the future plans. Yes. Failure adjust the decision logics. So this is a self improving, this is not a statics. So this flow shows how an agentic AI system plan tasks, execute them via multiple agents, makes decisions safely, remember context, observe itself, and continuously improves before responding to the users. So this is all about the architectural flow of goal and setting, monitoring agentic design patterns. So that's all for today. If this video helped you to understand the goal setting and monitoring agentic design pattern, don't forget to like, subscribe, and share. See you in next one. Thank you.